the fraction 1/3. This is called a proper fraction. Why is it proper? Because the numerator, the top number, is less than the denominator. So any fraction where the top number is smaller is called a proper fraction, right? That's how most fractions are. They describe something less than 1. So we look at this example. This is the fraction 1/3, because you can think of a circle being divided into, this would be 2/3 and this would be 3/3. And of course, this is one circle cut into 3 pieces. If we only have one of those pieces, we have 1/3. So this is a proper fraction. All right, what would be, for instance, another example of a proper fraction? Let's take a look at the fraction 2/3. This, of course, is also proper. Why? Because the top number is smaller. So any fraction where the top number is smaller is a proper fraction. This fraction would be represented by this amount of pizza or pie or whatever you want to talk about. 2 pieces when the circle is cut into 3 pieces. 2 out of 3 pieces. That's what this means. This is 1 out of 3 pieces. Now let's take a look at our first improper fraction. And the improper fraction we're going to use is going to be 5/3. Now notice the difference between this and the other ones. The top number is actually larger than the bottom. So any fraction where you have the top number larger than the bottom number, we call it an improper fraction. So this one is called improper. Improper fraction. And it turns out that all of these improper fractions, we can turn them into mixed numbers, which I know we have talked about and learned in the past. A mixed number would be like 1 2/3, 3 3/4, 5 and 5/7, something like that is a mixed number. So any of those mixed numbers can be turned into improper fractions, and any of these improper fractions can be turned into a mixed number. So what we're going to do here is learn how to turn any improper fraction into a mixed number. So before we actually calculate the answer, I want to show you graphically what it means. If this is the fraction 1/3, that means 1 piece out of 3 slices, and this is 2/3, 2 pieces out of 3 slices. What is 5/3 going to look like? Well, we're counting in terms of thirds. So this is 1/3, this is 2/3, just count in terms of thirds, 3/3. Notice that makes a whole pizza right there, but we still have to go higher because 3/3, 3 out of 3 is just 1 whole. But now we have to keep going up. Here's 4/3, and then finally we would have 5/3. So look at what we have here. We have visually, without actually doing any math, we can see that 5/3, because the top number is bigger, it means that we have more than 1 whole. Because remember, when the top and the bottom number are both the same, 3 out of 3 is 1. 5 out of 5 is 1. 10 out of 10 is 1. So anytime the top number is going to be bigger, it means you must have more than 1 whole pizza, for example. So 1, 2, 3, 4, 5 slices, when they're cut into thirds, means we have 1 whole plus what's left over. What do we have here? This is 2/3 of another pizza. So without doing any actual math, we can see immediately that 5/3 is exactly equal to the mixed number 1 2/3. So we can kind of circle this, and we can say that these 2 things are exactly the same thing. There is no difference at all between saying that you have 1 2/3 of a pizza or saying that you have 5/3 of a pizza. They both mean the same thing. It's just like saying, it's like different words of language. You might say something is beautiful and you might say something is pretty. Yeah, there's slight differences there, so the analogy is not perfect. But you get the idea. We have different ways of talking about things, and in math we have the same thing. We have the improper fraction way of expressing this much pizza, 5 slices when they're cut into thirds, and we also have the mixed number way, 1 whole pizza plus another 2/3 of a pizza. Now what we want to do next is figure out, without using any of these magnets, how do we actually get the right answer? How do we calculate this here? So what we have to do is, remember, we talked in the last lesson that fractions are all about division. So when we have the fraction 5/3, what we're saying is this means 5 divided by 3. Remember from the last lesson, every fraction can be written as division. In this case, it's 5 divided by 3. Now, if you actually take the number 5 and you actually divide it by the number 3, this is how you would write the division of this, 5 divided by 3, 5 divided by 3. So let's go and do this division. Well, 3 times something is 5. You can say 3 times 1 is 3, 3 times 2 is 6. That's too big. So it has to be 3 times 1 is 3. Then we multiply. 3 times 1 is 3, and we subtract, and we get a remainder of 2. So what we say is that the answer to this problem is when we take 5 here and we divide it by 3 here, the answer we get is it goes one whole time. Notice that means we have one whole pizza here. And what is left over? A remainder of 2. What does it mean to have a remainder of 2? We're talking about slices of something. We have 2 slices left over when they're cut into thirds. So it means that when we do this division, we have one whole pizza with 2 slices left when the pizza's actually cut into thirds, 1 2/3. So the way that we convert a improper fraction to a mixed number is just to do the division. That's all we have to do for every one of them. All you have to do is write it down and do the division. Whatever remainder you get, you just stick it over what you were dividing by, and then you have your whole number, of course, here, and then that is the mixed number. Because when we do this division, it goes one whole time, and the leftover is 2 slices when they are cut into thirds. So for the rest of these problems, we're going to do it both ways. We're going to show graphically, and then we're also going to calculate. Let's go ahead and crank through several more problems to get more practice. Let's take a look at the mixed number 3/2. 3/2. Before we do anything, let's see if we can figure it out without actually doing any math. We're saying we have 3 slices, but all of the slices are actually in sizes called halves. So for instance, here's 1/2, right? But we don't have 1/2, we have 3/2. So here's 2/2. Oops, that makes a hole right there, doesn't it? And then we have this guy over here, 3/2. 1/2, 2/2, 3/2. What does this mean when we look at what we have here? What this means is that we can see graphically that 3/2 is the same thing as 1 whole plus another half, 1 1/2. And so, of course, this is the answer graphically. But let's figure out how to do it without using graphically. When we say 3/2, we're saying that this is a division problem. 3 divided by 2. 3 divided by 2. We just have to do the division. Now, divide. 2 times 1 is 2. 2 times 2 is 4. That's too much. 2 times 1 is 2. Multiply, subtract, and we get a 1. That's the remainder. So what does this mean? It means when we take 3 and we divide it by 2, what happens? It goes one whole time. One whole time. That's why we got this. And the remainder was a 1, and we put it over what we were dividing by, over the same denominator of the original fraction, in other words, 1 1/2. So essentially all you do is you divide, you get a whole number, whatever the remainder is, you stick it over the denominator of the original fraction because it's 1 slice left over as a remainder when the slices are called halves. So you get 1 1/2. All right, now for the next problem, we're going to do it a little backwards. We're going to calculate first and then verify with our pictures that everything is right. Let's take a look at the improper fraction 8/4. Top number is bigger, so that's an improper fraction. What does this actually mean? This means that I have 8 and I divide it by 4 because fractions are always division. 8 divided by 4. So let's see what happens. 4 times 1 is 4. 4 times 2 is 8 exactly. 4 times 2 is 8. Subtract, get a 0. The remainder is 0. So there is no remainder. We don't have any fractional leftovers at all. The answer is just 2. And so we think that the improper fraction 8/4 is exactly the same as 2 wholes. But that seems weird. How can these things be equal? Let's see. We're saying in our original problem we have 8 slices in terms of fourths, or 8/4. That's what we have. Here's 1/4, 2/4, there's 3/4, there is 4/4, but we don't have 4/4. 4/4 would be 1 whole. We have 8/4. 5/4, there's 6/4, there is 7/4, and there is 8/4. Notice we have 2 whole pizzas, and that's why we got an answer of 2. So we can see from the magnets that 1, 2, 3, 4, 5, 6, 7, 8/4 is exactly equal to 2 wholes. So when you convert these improper fractions, sometimes you get a whole number and you won't even have a fractional piece to it. All right, let's take a look at the problem, improper fraction 7/6. 7/6. Let's go ahead and calculate that. What does this actually mean? This means division. It means 7 divided by 6. So this means that I take the number 7 and I divide it by the number 6. Let's crank through this. 6 times 1 is 6. 6 times 2 is 12. That's too big. So it has to be 6 times 1 is 6. Multiply and subtract. 7 minus 6 is 1. and this is the remainder, one slice left over. So what it means is that when I do this division here, 7 divided by 6, the answer I get is it only goes one whole time. But I have a remainder of 1, and I put it over what my original denominator was, what I'm dividing by, 1/6. So 1 piece out of 6 left over. The answer is 1 and 1/6. Whatever remainder you get, you just put it over the same denominator over there. Now let's see if we can convince ourselves that this is actually correct. How many 6 do we actually have? We have 7/6. Now think about it for a minute. 6/6, or 6 out of 6, would just be 1 whole. We have a little more than that, so we expect it to be a little bit more than 1. Let's take a look. We have, here's 1/6, here's 2/6, here's 3/6, here's 4/6, here's 5/6, and here is 6/6. Of course, we have more than that. We have 7/6, which means we have this left over. So altogether, it means we have 1 whole pizza plus 1/6 of another pizza, 1 and 1/6, and that's why that works out. So I'll kind of just move this over here and stick it over there, and we just keep it there. All right, so once you get the hang of this, it's actually not very hard. So let's crank through more problems to make sure we understand. Let's take a look at the improper fraction, 9/5. Top number is bigger, so of course it's improper. And what does this actually mean? Well, in terms of division, we take the number 9 divided by 5. 9 divided by 5. All right, so what do we have? 5 times 1 is 5. 5 times 2 is 10, so it can't be 2, it has to be 1. 5 times 1 is 5, and then subtract, 9 minus 5 is 4. So what we're saying is when we divide this thing, it goes one whole time with a remainder of 4, and we just put it over the same denominator, 1 and 4/5. So this improper fraction of 9/5 is exactly the same thing as 1 and 4/5. Let's make sure and see if we agree that this is the case. We said we had 9/5, so we're going to count by fifths. Here's 1/5. Here's 2/5, here's 3/5, here's 4/5, here's 5/5. That makes a whole right there, but we have 9/5. We have to keep going. 6/5, 7/5, 8/5, and here is 9/5. So that's what we have. 1, 2, 3, 4, 5, 6, 7, 8, 9/5. We have 1 whole pizza plus 1, 2, 3, 4/5 of another pizza, and that's why the answer that we got there makes sense. All right, cranking right along. Let's get a little more practice. Let's take a look at the improper fraction 8/6. We treat it as a division problem. 8 divided by 6. 8 divided by 6. 6 times 1 is 6. 6 times 2 is 12. That's too big. Has to be 6 times 1 is 6. Subtract. 8 minus 6 is 2. The remainder is 2. So what we figured out is that when we do this, it goes one whole time with a remainder of 2 left over, and we put it over the same denominator, 2/6. Now, we have to think a little bit here, because this is the right answer. However, we can look at this 2/6. It is correct, but 2/6 can be simplified further because they're both even numbers. See, we didn't have to simplify this. This was already simplest. This was already simplest. We couldn't divide top and bottom of any of these other fractions by anything to make them simpler, but we know that we can simplify fractions by dividing the top and the bottom by any number we want to make it simpler. We can divide these by 2. So we can say 1 and 2/6. What I'll do is I'll say, well, I'll just divide the top by 2, and I'll divide the bottom by 2, and that gives us an answer of 1, and 2 divided by 2 is 1, and 6 divided by 2 is 3. And so the answer we get is 1/3. Now let's really take our time making sure that we understand this. We had 8/6 here. We had 8/6. So let's go ahead and do it over here. Here's 1/6, 2/6, 3/6, 4/6. If I can get my magnets right. Here's 5/6, and here is 6/6, like this, 6/6. But we don't have 6/6, we have 8/6. So here is, after 6/6, here's 7/6, here is 8/6. So notice what we got. We got an answer of 1 whole plus 2/6, 2 out of 6 pieces. That's exactly what we initially calculated. 1 and 2/6 is the correct amount of pizza. But we can simplify this because we can say this is a whole, and then we can also say, well, wait a minute, 2/6 like this is exactly the same amount of pizza as 1/3. Notice how they line up exactly. So 1 whole and 2/6, which is this fraction, is the same as 1 whole and 1/3. They're just different ways of writing the same amount of pizza. So that's why we say this is the simplest one, and that's the one we're going to like the best. All right, we just have a few more problems, and then we will be done. We'll crank up probably the speed just a little bit. What about 23 tenths? Well, we can treat it as a division problem, just like all of these guys. We can say 23 divided by 10. All right, well, 10 times 1 is 10. 10 times 2 is 20. That's as close as I can go. So I can put a 2 here, multiply, get a 20, subtract, get a 3. And the remainder is 3. So what does this mean? It means that when I divide this, I get a whole number of 2 with a remainder of 3, and I put it over the same denominator, over 10. So it's 3 slices left over when they're cut into tenths. So the answer is 2 3/10. I cannot simplify 3/10 anymore because I can't divide top and bottom by the same number and make it any simpler. So let's see if this actually makes any sense. So I actually have tenths here, and I have 23 of these tenths. So let's take a look. Here's 1 tenth, here's 2 tenths, 3, 4, 5, 6 tenths. See if I can squish them together here. There's 6 tenths right there. And then there's 7 tenths, 8 tenths, 9 tenths, and then here's 10 tenths. I know it looks a little ugly, but I'll push them together. There's 10 tenths. Well, let's keep going because we actually have 23 of these things called tenths. There's 11 tenths, 12 tenths, 13 tenths, 14 tenths, 15 tenths, 16 tenths, 17 tenths, 18 tenths, 19 tenths, 20 tenths. Okay, 20 tenths, but I'm still not done. I have 23. So there's 20 tenths. Here's 21. Here's 22. Here's 23 tenths. 23 tenths. What do I get as an answer? 1 whole pizza, 2 whole pizzas, 3 tenths. 1 tenth, 2 tenths, 3 tenths. There's 2 wholes plus 3 tenths. And that's why this is exactly the same amount of pizza as what's represented there. 2 3/10. And we can circle that to be our final answer. All right, we only have a couple more and then we are done. Let's take a look at 26 fifths. I think at this point we can probably stop using the magnets. We understand the concept here, and now we can just crank through the division and get the answers. We take 26 and we just divide it by 5. Divide by 5. And then what do we say? Well, 5 times 4 is 20. 5 times 5 is 25. And then 5 times 6 is 30, but that's too big. So it has to be 5 times 5. That's going to multiply, give me 25, and subtract, and I'll get a 1 left over as the remainder. So what this means is that in the end of the day, when I divide this, I have a whole number of 5. It goes 5 whole times, and the remainder I have left over is just 1 out of 5, or 1/5, because it's 1 slice left over, but they're cut into fifths. So the answer is 5 1/5. And of course, if I had, fifths, a bunch of fifth slices of pizza and did 26 of them, I would find out that it would make 5 wholes, and I would have a little bit left over. All right, almost done, I promise. Only 2 more. And the answer, or the question here is 24/8. Okay, 24/8. So 24 divided by 8. 24 divided by 8. All right, what do we do? 8 times 3 is exactly 24. 8 times 3, 24. And then, of course, a remainder is 0. So when I do this division, it goes 3 whole times. No remainder at all. So there's no fraction to write here because there's no remainder. I've done the division, it divides exactly. And so if I had 8s like this and put 24 of them together, I would find that it would make 3 whole pizzas with nothing left over. And now I have our very last problem. Let's take a look at 13/4. And of course, as always, we'll write this in terms of division. This is 13 divided by 4. 4 times 3 is 12. That's as close as I can get. When I multiply, I get 12, subtract, and get a 1. So what this means is that when I divide, it goes 3 whole times with a remainder of 1 slice left over, but they're cut into fourths. So the answer is 3 1/4, and that is the final answer. So I really hope that by using the pictures, the models that we have, along with doing the math, you can understand that any improper fraction you have must represent something bigger than 1. How do we know that? Because anytime you have 3/3, for instance, that's just 1 whole. 5 over 5 is 1 whole. 6 out of 6 is 1 whole. 10 out of 10 is 1 whole. So anytime the top number is bigger than the bottom number, it must be larger than 1. And so to get the answer, we just do the division. The remainder that we have just gets expressed as a fractional leftover, and then we call it a mixed number. That's all it is. So I'd like you to solve every one of these problems. And then, follow me on to part 2, we'll get a little more practice with converting improper fractions to mixed numbers. Learn anything at mathandscience.com.